Hello, this is Mrs. Caldwell, and welcome to another 3C Let's Do Math video, where we'll be talking about an introduction to cosine law today. So our topic today, using cosine law to solve non-right triangles. I can use cosine law to solve for angles and side lengths in, that should say non-right triangles. I made a mistake there, ladies and gentlemen. Let's go and put the word non in here. In non-right triangles, where I am unable to use sine law. So what does it mean you're unable to use sine law? Thought you said in the last video that we can use sine law in non-right triangles. Yes, I did, ladies and gentlemen, I did say that, but I also told you you had to have an angle side pair to use sine law, and there are two instances where you do not have that. Case one we call the Pac-Man. You have values for two sides and the angle between them, and you need to find the last side in the triangle. So we're talking about this one, ladies and gentlemen. I'm going to use my highlighter here to show you what we're talking about. Case one, the Pac-Man. Why is it called the Pac-Man? Well, look, we've got this mouth here and we got this mouth here, and it's eating the angle in the middle. Looks an awful lot like Pac-Man to me, doesn't it? To you too? Okay, so the Pac-Man, we've got two sides with the angle between them. There is no angle side pair there. I do not have a side down here across from that angle, and I do not have angles across from either of those two sides. So sine law is useless. Case number two, you're surrounded. What does that mean? Well, you have values for all three side lengths. If you have all three side lengths, you have no angles, so you cannot possibly have an angle side pair with values on it. So in these two instances, you are going to be able to use cosine law. What is cosine law, did you ask? I'm glad you're asking that question. That shows that you are being inquisitive. In this case, we need to introduce the law of cosines. Now, it looks complicated, but it's actually just a slight offshoot of the Pythagorean theorem. So here's the law of cosines. It says, for any triangle ABC, where little a, little b, and little c are the opposite sides opposite the angles big A, big B, and big C, respectively, the cosine law states, well, it states, and look, if I took this off of here, this is just Pythagorean theorem. C squared equals A squared plus B squared. But we have to adjust because Pythagorean theorem only works in a right triangle. Since this is not a right triangle, we have to make an adjustment for the angle, which is why we have to put this gobbledygook in here, minus 2AB cos C. So if you're looking for a side, you're going to use this one because this is a side. So since this is a side, this formula finds a side. Now we can rearrange that formula, and I've already done it to you. You don't have to know how to rearrange it. You just have to know how to apply it. So this is actually the rearranged version of it. I just swapped a bunch of stuff around here and got this thing. And we use this one if we want to find an angle, because we've got the angle on this side. So let's actually put them to some use here. Okay, example number one, solve for a side length using cosine law. This is the Pac-Man situation, because if we're solving for a side length, this is the side length we're solving for. We've got these two sides with the angle between them, and we want to solve for the last side, which is across from the angle. So here's how we fill it in. Again, you're saying, hold on, Mrs. Caldwell. There's no A, B's, and C's. How do we do this without A, B's, and C's? The triangle has Q, R, and S in it. And I said, now don't worry, ladies and gentlemen, just don't worry. We know how to fix this. So here's the deal. This is the side you're solving for, C. So instead of C, we're going to put a Q, because in this triangle, it's Q we're looking for. So we put Q squared. Now across from the Q is side big Q. And notice here we had a C and a big C. So it's actually big Q that needs to go in where this big C is. So this 89 degrees is going to be on the end here as cos 89. So we're going to write, oops, I lost my pen for some reason. We're going to write cos of 89 degrees on the end. And the other two sides are what makes up the A's and B's in here. So we go 28 squared plus 16 squared minus 2 times 28 times 16. And we just fill it in like that. Now, here's how we're going to write it down. I'm going to pull out my calculator. First thing I'm going to do is I'm just going to type into the calculator 28 squared plus 16 squared. So 28 squared plus 16 squared. You can do it all at once in the calculator and I get 1040. Now I'm going to do this part now. So these are the two things that I'm doing in this line. Now I'm going to multiply 2 times 28 times 16. So 2 times 28 times 16. And I get 896. So I get 896. And now we have the cos of 89 degrees. Now I'm going to tell you one mistake that a lot of people make at this point. They say, oh hey, I can subtract this here. I can do 1040 minus 896. And I would say, stop, no, don't do that. You are violating the laws of BEDMAS, because remember, order of operations says that you must do multiplication before you do subtraction. So what we have to actually do here, and I think I just erased more than I wanted to there, so there we go. What we must do in the next line, and I'm going to do that in pink highlighter, is this part. Okay, I have to do 896 times the cos of 89. So where's my calculator? 896 times 89 cos. And now I have to hit equals. Don't forget to hit equals. That says 15.6374. So that's 15.6374. So let me get my pen again. 16 point, I forgot it again. Gosh, my memory's going. And it's 15. 15.6374. 15.6374. And of course that 1040 doesn't do anything. Now I have to do that subtraction. So now I'm going to do the subtraction, and it's going to be 1040 minus 15.6374 equals 1024 3626. 1024.3626. Now, is that our answer? Well, that would be a pretty funny triangle if this side was 28, this side was 16, and then this side over here was 1024. So we're not done. In fact, that is actually q squared. And so to find out what q is, remember in Pythagorean theorem, what did we do? We did this, right? That, you remember what that is? Square root 1024.3626. Taking the square root. And now we're going to do that on here. I've left that on there, so I'm just going to hit the square root button. And that's 32. Almost 32 exactly. So 32, it isn't 32 exactly, it's 32.0, but we're going to put the approximate sign here. And of course that's in centimeters, so we're going to put that there. Okay, so that's solving with the side length. Now I'm going to do solving for an angle using cosine law, which is the you're surrounded situation. If I've got all three sides like here, I've got my triangle surrounded, and I'm going to find an angle. So this says solving for an angle, and the first thing here is I can solve for any angle I want, and I may actually solve for two, so you understand where this is coming from. We're going to start by solving for, let's just say Q. Let's solve for Q. Q's a nice letter. Q's an underrated letter. A lot of people don't like Q because it has to have a U with it. But anyway, if we're solving for Q, that's what's going to go in here. Cos of Q. Now, how do we know which numbers? We've got a lot of numbers here. Well, across from Q is little q. And here we had a big C and a little c. So the biggest thing you need to remember here is whatever angle you're finding, this subtracted one over here is the side across from it. So minus 18 squared. Now everything else fills in exactly, fills in the other ones. 26 squared plus 24 squared, and then we do minus the side across from the angle you're finding, over 2 times 26 times 24. Now I'm going to type that into the calculator in a minute, but I'm going to say, what if we were finding the other angles? I'm going to do this in a couple of different spots, or for the other two angles. So let's do this one in red, shall we? If I wanted to find R, I start by writing down cos R. And then the two angles around R are going to be our A and our B. So we go 18 squared plus 24 squared. And the subtracted one, remember, has to be the one across from R. So that's minus 26 squared. And then divided by these first two. Okay, the bottom is the A and the B, like was up here. So the first two are 18 and 24. And don't forget that we have to put a 2 out in front. So that's if I were finding R. I'm going to do it one more time. This time I'm going to do it in green. And say, if I were finding S, I write down cos S. And then I'm going to write down the angles. The A and the B are the two things that make up angle S. So the 26 and the 18. So we would go 26 squared plus 18 squared minus, and the minus one, the one that is the minus, like these ones can be written, I could have put 18 squared plus 26 squared. Those can be in any order you want, but the minus one, the one with the minus sign in front of it, is the side across from the angle we chose to find. So that's going to be minus 24 squared. And of course that's going to be divided by 2 times those first two again, 26 times 18. Now, how do we type this into the calculator? It's actually pretty straightforward. I'm going to go up here. Let's pull up my handy dandy calculator. And I'm just going to type that in. 26, here, watch me, I'm going to clear it first. 26 squared plus 24 squared minus 18 squared equals, and that's 928. And I'm going to write that down. 928. Now I'm going to do the bottom part. So here's what I did. Let's use this highlighter again. I like my highlighter. I'm going to use this blue this time. What I did was I did the top and I got this. Now, yellow, I'm going to do the bottom and I'm going to put my answer there. So let's go back to my handy dandy calculator and I'm going to go 2 times 26 times 24. And that's 1248. So I'm going to write in 1248. And then we're going to actually do that division because that's what this thing means. That's a division. I'm going to put this little thing in here and I'm going to say division. And we're going to go 928. 928 divided by 1248 equals, and I get 0.7436. 0.7436. Now that is the cos of Q. Do you remember how we get Q? I hope so. We've done it quite a few times. How I get Q, how I get the cos away from Q. I have to use inverse cos, which is cos negative 1. 0.7436. And I'm running out of room here. So I'm going to very quickly go here and go inverse cos because I've still got this number here. So all I have to do is go shift and cos. And it's 41.96 or approximately 42 degrees. Now, what I'm going to do here is I'm going to put you on pause and I'm going to very quickly finish off the other two things. What I would like you to do is put me on pause and you very quickly finish off these other two things and see if yours matches mine. Okay, here I go. I'm going to pause. Hello, I'm back. Did you figure it out? Do your answers actually match? Is the word I'm trying to get out here, match mine. And notice I did a little check here as from once I got all three of my answers here, so I've got angle S is 63 degrees, angle R is 75, and of course we solved together, angle Q is 42, and I just did a quick check. I added up all of those angles since they're in a triangle, and I got 180 degrees. So that actually works pretty well. So now what I would like you to do is some of these on your own. So that concludes this video. Thank you and bye.